This video is about projectiles, and it's really just SUVAT in 2 dimensions. So we've got a particle projected from a point O on a horizontal plane with speed 28 meters per second, and it makes an angle of elevation 30 degrees. Let's do a little sketch of that. So this is 28 meters per second. This angle here is 30. So we can resolve this in 2 dimensions, 28 cos 30 horizontally and 28 sin 30 vertically. Now the trick with this, I think, for every situation is to resolve in 2 dimensions and to write down SUVAT horizontally and to write down SUVAT vertically. So in part A we've got we need to find the greatest height above the plane reached by P. So the greatest height is going to occur when the final velocity vertically is 0. Just make sure you understand that. We've got a particle going up, so the greatest height at the top is going to be when it's got no vertical velocity. We've already worked out that the horizontal speed initially is 28 cos 30 and vertically it's 28 sin 30. Horizontally there is no acceleration, but vertically we've got the acceleration due to gravity, so that's minus 9.8. So I've chosen to take my upwards as the positive direction. I don't need to do that. I could take downwards as the positive direction, in which case that would be plus 9.8. So what we're after is the greatest height, so let's call that h. So as it happens in this question, we're not really interested, in part A anyway, we're not really interested in anything to do with horizontal motion. We can simply use SUVAT vertically. So we're not interested in the time in part A. So what's the SUVAT equation without t in it? Well, it's v squared equals u squared plus 2as. So let's now substitute in. V is 0. 28 sin 30, well sin 30 is a half, so that's 14, so it's 14 squared. Although there's a plus in the formula, the minus sign here is going to make this a minus, so it's minus 19.6s. So from that we can work out that s is 10 meters. Okay, now let's look at part B, where we want to find the time of flight of P. P is where it hits the ground. So we've still got the same initial velocity, and I've done the same setup here, the same table, horizontal and vertical, and we're going to do SUVAT. So the initial velocity horizontally is 28 cos 30, and the initial velocity vertically is 28 sin 30. There's still no acceleration horizontally, but we've got minus 9.8 vertically. We want to find the time of flight of P. So P is the point at which it lands. So the point at which it lands, the vertical displacement is 0. And it's t that we want to find. So once again, the horizontal components are not needed, but it's a good idea to always write these down. And what we can look at is the vertical components here. It's v that we don't know. What's the SUVAT equation without v? Well, it's s equals ut plus half at squared. So s is 0. 28 sin 30, that's 14. A is minus, so it's going to be minus half of 9.8 is 4.9 t squared. So from that we can say that t is a factor. So either t equals 0, which it clearly is, because at the start the particle is level with the ground. So t equals 0, it's got no displacement. Or 14 minus 4.9 t is 0. So t works out to be 2.9. That's two significant figures. Now let's look at part C. We want to find the distance OA. I've drawn all this out again, but you don't need to keep doing this. It's just I'm going from one slide to another to make it clearer. So you don't need to keep drawing this 3 times, you've done that in one instance. But you do need to draw this out again, because in part A we had a different scenario to what we had in part B and C. Okay, so what we've got now, we need to find the distance OA. We've just worked out the time of flight to be 2.9, so we can put that in here. And obviously the time of flight to get to A is the same in both cases. So now we're going to be using the horizontal components, and we need to work out the distance S. Let's call that x. Oops, there we go. So what we've got here is the Suvat equation without v. So that's S equals ut plus half at squared. Because there's no acceleration, it's simply distance is speed times time. So the distance is 28 cos 30 multiplied by 2.9 plus 0, because there's no acceleration. And this works out to be 69 meters to 2 sig figs. So this work on projectiles is simply Suvat in 2 dimensions. But I strongly recommend that you always set out your table like this, horizontal and vertical, and you always draw this diagram just to make it clear what's happening.